Welcome to Saucy Math. This video will be about factoring using special formulas. So there's really three formulas that I think are important when you're trying to factor an expression. So we'll just kind of go through those. Now the first one of these is definitely the one that you'll see the most often, and it's called the difference of squares formula. So if you have something in the form of a squared minus b squared, right, where something, some perfect square minus another perfect square, that factors into the formula a plus b times a minus b. All right, so this formula here is a pretty easy formula to use as long as you can recognize when to use it, and then obviously you have to remember what the formula is. All right, so if we look at the example of this, we have 9x squared minus 25. All right, so we have the subtraction here, which is a difference. Now we just have to check, are our two terms, the 9x squared and the 25, are those both perfect squares? Well, 9x squared, 9 is a perfect square, right? Because 9 is 3 times 3. And x squared obviously is a perfect square because it's x squared. Right? So we could rewrite that as 3x in parentheses squared. Right? That's what 9x squared is equal to, is 3x times 3x, 9x squared. Right? Minus, and then 25 is also a perfect square, right? Because 25 is 5 squared. All right, so it's like the 3x in this case is our a, and the 5 is like our b in this formula that we talked about over here. Right, so once we recognize that we have a difference of two squares, and remember, it has to be a difference. This has to be subtraction here. If this was addition, then we would not be able to factor this. Right? There's no formula for a sum of squares, only for a difference of squares. All right, so 9x squared minus 25, if we factor it, remember it's a, right? So 3x plus b, which is 5, and then multiplied by the same thing, but change the plus to a minus, 3x minus 5, and that is our factoring of the difference of two squares, 9x squared minus 25. All right, like I said, if you know what the formula is, it's pretty simple to do. You just have to recognize that you have one perfect square here minus another perfect square, and basically you just take the square root of each term. So the square root of 9x squared is 3x. That's going to go in the beginning of each parentheses. The square root of 25 is 5. That goes at the end of each parentheses, and then just put one plus and one minus in there, and you got it. Right, and just like any other factoring, if you multiply all this stuff back together over here, you should end up with the same exact thing that you started with at the beginning. All right, so that's the difference of squares formula. Like I said, of the three formulas that we'll talk about here, that's the one that you're probably going to see most often. All right, the next formula is what we call a difference of cubes formula. Right, similar to a difference of squares, but instead of a squared minus b squared like it was before, now it's a cubed minus b cubed. Right, so two perfect cubes being subtracted. Right, and the formula to factor a difference of two cubes is a little more complicated. It's a minus b times a squared plus ab plus b squared. Right, and kind of towards the end of this video, I'll show you a little way to kind of remember this formula, because the next one we look at, the sum of cubes, is similar to this formula but a little bit different, and I'll show you how to kind of remember how to put it all together. Right, so the example we have here, 27x to the third power minus 8. Right, so is this a difference of two cubes? Well, 27 is a perfect cube. I almost said a Pufict cube. 27 is a perfect cube because it is, 27 is 3 raised to the third power, and x to the third power obviously is x raised to the third power. Right, so 27x to the third is 3x in parentheses raised to the third power. And then 8 is also a perfect cube because it's 2 raised to the third power. All right, so when you're doing this difference or sum of cubes formula, it helps to know what the perfect cubes are. All right, 2 to the third power is 8, 3 to the third power is 27, 4 to the third is 64, 5 to the third is 125, and so on. So if you know those numbers, it makes it a lot easier to recognize, when you see the 27 and the 8, if you just know right away those are perfect cubes, it makes it a lot easier to do this. All right, so then if we use our formula, right, so it's a minus b, so it's kind of like the base or the cube root of each of these. All right, so it's 3x minus 2. All right, that's going to be our first parentheses. And then our second parentheses, we take the first one, the 3x squared. All right, so 3x times 3x, which is going to be 9x squared. And then we take our two terms here and multiply them together, 3x times 2. So it's going to be plus 6x. And then we do our last one squared, 2 squared, which is plus 4. All right, that's our b squared at the end here. All right, so in this case, our a was like the 3x, our b was like the 2. All right, so it's a minus b, so just the 3x minus the 2 in the first parentheses. The second parentheses, we start with a squared, so 3x times 3x All right, so 9x squared. Then we do a times b, 3x times 2, that's plus 6x. And then we do b squared, right, 2 times 2, which is 4. Right, and that would be our factoring for this difference of cubes formula. And if you notice, when you factor with the difference of cubes formula, what we end up with at the end here is a quadratic expression, a quadratic trinomial. That expression there will never be able to be factored any further. Right, that's just kind of part of how the difference of cubes works. So don't waste your time trying to say, well, I have this thing here, maybe I can factor this some more. With this difference of cubes formula, that's never going to work. So you can just kind of leave that alone and be done with it. All right, the next formula we have is the sum of cubes formula, which looks a lot like the difference of cubes formula, but it's a sum instead of a difference, right? So a sum means addition. So if we have a cubed plus b cubed, right? So two perfect cubes that are being added, that factors into a plus b times parentheses a squared minus ab plus b squared. Right, so it looks a lot like the difference of cubes formula. The difference between them, right, for the difference of cubes, if I kind of write this right up above so we can kind of compare them, a cubed minus b cubed, right, the first parentheses is a minus b. Right, so the sign in your first parentheses always matches the sign in whatever you started with. Right, if it's a cubed minus b cubed, you start with a minus b. If it's a cubed plus b cubed, you start with a plus b. Right, so these signs always match. And then our second parentheses is always going to be an a squared, an ab, and then a b squared. The b squared is always plus. All right, so that's the last one is always going to be a plus. The a squared is always going to be a positive. And then the only difference is that the a be in the middle. Right? The sign of that middle term is the opposite of whatever sign you had in the beginning. Right? So if this first term is a minus b, I change that to a plus when I go to the second parentheses. Right, if it's a plus b, I change that to a minus when I get to the second parentheses. Right, so both of these formulas share that same pattern as far as how to put it together. Basically, two signs change. The sign in the first parentheses changes when you have the sum or the difference, right, and it always matches what you start with. And then the sign on your middle term changes. That's always the opposite of whatever the sign was in your first parentheses. All right, so that's kind of hopefully an easier way to memorize these formulas, because these are the kind of things that you do kind of have to memorize the formula. There's no real easy way to kind of put it back together if you don't know it. You just kind of have to remember what the formula is and be able to use it. All right, so if we look at this example with the sum of cubes, we have 64 plus 1000y to the third power. Right, so 64 is a perfect cube, right, because that's 4 to the third power. All right, and then is 1000 y cubed a perfect cube? Well, the y cubed definitely is. 1000 is actually 10 to the third power. So we can write that as 10y parentheses raised to the third power. All right, so our a is the 4 and our b is the 10y. So when we factor this, it's going to be a plus b. So 4 plus 10y. Remember, this first parentheses here always matches the sign of whatever it is where you started with. So if we have a sum here, a plus, this first parentheses has a plus. All right, second parentheses, we take the first thing we have here and square it. So 4 times 4 is 16. Then we take these two and multiply them together. 4 times 10y is going to be 40y. And whatever sign this is, we use the opposite sign over here. So it's going to be minus 40y. Then we take the last thing we have here and square that. So 10y times 10y is going to be plus 100y squared. And that's our factoring using that sum of cubes formula. All right, so those are the special formulas that we use for factoring. The sum and the difference of cubes don't come up that often, but every once in a while you'll be doing a problem and something like this, 64 plus 100y to the third power, is going to pop up, and then you kind of have to know the sum of cubes formula in order to factor it, otherwise you're just kind of stuck. All right, so they are important to know even though they're not that prevalent. Like I said before, the difference of squares formula that we started with at the beginning, that one you'll definitely see a lot more often. And that's the last of the videos that I'm going to do on the different types of factoring. So make sure you check out all those factoring videos that I've done. I think I've done 5 of them with all the different methods. There's the special formulas here. I did one on factoring by grouping. I did one on factoring by looking for a common factor. There's one on factoring a quadratic trinomial, and another one using what we call the AC method for the more difficult types of factoring. So make sure you check out all those, because you're going to see all those different types of factoring as you move through algebra and pre-calculus and calculus, and they're all going to be pretty important things to know.